notes for purpose of clear reference. So you can just open that up. Okay, so first of all, I hope all of you are very okay with your assignments. Like I told you, some of the work that I'm sharing with you is part of your self-management. We are teaching you problem-solving skills. You don't only have to look at me for solutions. There are solutions within you. So what I've done, some of those assignments, putting there, I know that you are used to waiting the lecturer there. But by the time you don't learn to work within yourself, collaborations, you remember? Some of the learning outcomes, you need to make sure that you can use your groups. You can maximally utilize people around you to solve, other than waiting and creating a chain. Government triangle. Those who are in Uganda, you know what that means. The mindset of thinking that the president come and help us, and yet he will never come. You understand what I mean? So you must always learn to start using the people around you. There are certainly those who understand these concepts. Teamwork. if you're not a friend to somebody who is next to you in class, if you're online and you're saying, oh, we are in 6th week and you're saying you can't see the link, you are certainly, those are already red flags. Yeah? You have this behavior for you came in school, I want the link, I want somebody to do this. You don't even have the ability to ask who is in this class, who can help me. Those are really dangerous behaviors. So part of it, make sure you get in touch with your colleagues if you don't understand. Because your cut, when I doing the cut? Maybe in 2 weeks, and you're just going to find the numbers like that. You understand? And then there are those who are going to say, oh, he never revised this. Oh, he never did this. As if, I don't know what you're waiting. If I've already alerted you that those numbers are going to come and you're still waiting for me, you are in trouble. So, we're going to look at propositional logic. Propositional logic. Now, in the field of science, or let me not even talk about field of science, different sectors of our lives, we have discovered methods of how things occur and make sense in that particular area. Okay? We have predefined, even if it's nature, we, for example, know how you will plant a seed that when you want to get a tree, you will take a seed, you will not put it on a rock, you will put it in soil, you will water, it will grow, it will bring out. You even know that it's going to take maybe 20 or so years. Okay? So there are certain patterns of how things occur, how they make sense. Now, in the field of computers, this topic of propositional logic is also very critical. We have two words, propositions, as we shall be able to define what they are, and then logic. At least you are used to the term logic. Yeah? It's not the first time you're hearing. When somebody says, be logical, what does it mean? If I say, be logical, this man is illogical, what do I mean? Yeah? If you are illogical, you are a critical thinker. Illogical. If I say you're not logical, yeah? Invalid thoughts. Thank you. So, there are some thoughts, even if you don't think about them, they just become invalid. Like I usually say, I ask, when you come from home, do you dress for us or you dress for yourself? Are you very sure? Now, that is what he thinks. But if I go through critically, you'll find that he actually does not dress for himself. You understand what I mean? If I ask him when he's in his bedroom, he puts on boxers. Why? Man, can you come here with boxers? Why not? Yeah? It's not fun. Yeah? The man is saying, it's not fun to come here. But he has not even thought that now here I am dressing because it's just automatic. Because it does not make logic to come here when you're in boxers, because boxers have where they belong. You understand what I mean? So those instincts have been instilled in you slowly by slowly. They have become automatic until you are not even aware that that is what is happening with you. Okay? So logic as a word is usually refers to science of correct reasoning. Science of correct reasoning. That is logic. So if I tell you are illogical, it means your thinking has some deficiencies. If, for example, you're expected to do work in a certain way, but your behavior turns opposite, then I will tell that, oh, this man is illogical, because it means there are things you are doing which an average person, or what is expected of an average person, is not coming out the way it is supposed to be. If, for example, there are two people who are quarreling, in the village. You can even know that this person, this is the state, this person is educated, this one is not educated. Is that true? Yeah? Because people who are not educated, it's as if they rehearse how to abuse. They have encyclopedias. Any small thing, they say, for me, I will deal with you immediately. Now remember, this one who is educated, you think about your status, you think about the repercussions. Critically, you analyze after this, what is going to happen? How am I going to be seen? This one has nothing to lose. You will say, I have to show this person what I'm made of. You understand the character of thinking. So, propositions from the word propose. The Valentine people. How many got proposals? Ladies, did you get proposal on Valentine? They did. Okay. Or they proposed long time. Yeah? But when we say a proposal, we look at, there are two ways for a proposal. Only two. Irrespective of the style that the man comes with. Yeah? But sometimes you have to do your homework, because don't go there. There are those who go and they're only expecting one answer, but once they get the other one, they become crushed. Man, always let your heart open, okay? So, but the point I'm trying to say, when you make a proposal, there are only two outcomes. What are they? Yes or no. Likewise, in computers, we're going to look at propositions. Whenever you make any statement, it does not matter whether that statement is true or false, but we only look at the statement that you are making in terms of whether it is correct or wrong. So we don't look at statements in terms of their actual value. We only look at that statement in the direction of whether it will end up into being a true or a false statement. So when we talk about proposition here, we are talking about declarative statements that are either true or false. And that's where the science of computer lies. Because computers are in form of binary numbers, which are ones and zeros. So the way in which we represent statements in the computer will be that every statement that is made and the context, we shall always end up assigning that statement to a 1 or 0, full stop. Even if you made a statement, Maganda is tall, it's now, the computer does not even want to know whether Maganda is tall or not. It will want to get an assigned value to whether that statement is true or false. It doesn't get bothered about Maganda. So if you say Maganda is tall, we can now use a standard of measure to find whether Maganda is tall or short. If it finds that Maganda is tall, it assigns 1. That's what the computer is interested. If it finds Maganda is short, it assigns a 0. Full stop. The details about who Maganda is, other character, it is not bothered until that particular propositional value that we are talking about has been assigned a value. Okay? So in brief, when we talk about propositional logic, we shall be looking at these statements. Okay? We should be looking at different types of statements, of which, of course, are assigned to computers. Some of them we are just going to look at basic statements that we use in our day-to-day life and how they can be converted from the language narrative into the mathematical computer narrative. And we shall also be looking at some of those statements which are in the computer binary narrative back into the human narrative. Okay? And by that, what we are trying to see, we shall be seeing how the computer is used to solve some of our day-to-day complex statements. Okay? Now, if you did literature or English, at least you also know what propositions are. Okay? And we shall later see that these propositions can be manipulated in different ways. Okay? You have certain connectives, what we call the logical connectives. that one proposition being combined with another proposition will produce a complex proposition. But the truth value for that complex proposition will depend on the type of connective that you have used to combine that proposition. Okay, now the question comes, where maybe let's define, then we can look at the application. So we're saying, what is a proposition? A declarative statement that is either true or false and must have a subject and a verb. Key takeaway, when we are talking about proposition, we are talking about a statement in terms of either being true or false. Okay? How do we represent the true or false? If a statement is true, usually we represent it using a 1. If a statement is false, we represent it using 0. So for example, if you say, you can make a declarative statement that we have said, for example, Maganda is tall. That one you have declared. But we need to ascertain the truthfulness in the statement that has been made about Maganda. So we can make by observation, okay? We can make by inference from another person who knows Maganda to find out whether that statement is true. Okay? And by the way, through this type of logic propositions, this is how the judges sit in courts of law and make decisions about our future. Yeah? I think I've made inferences to you, because does it make sense for somebody to commit murder in Kansanga? Okay? And then the judge, who is busy there in the High Court, going into seminars where he sits there and makes a conclusion about your future, when he was not actually even there. At least you would say, let's get borders or something like, you understand what I mean? But it's through this, the system of thinking, the logic. Okay? So here, while we are talking about the computer logic, you will get now that also is, you will get the legal logic. The legal logic, everything you do, you can speak 1, 2, 3 things, and we can know that you are lying. And if we all agree, if there are 5 people who make an assessment of what you are saying and it's not making meaning, then for you, you are guilty. Yeah? Is it fair? Do you trust that system? You don't trust. Okay? Yeah, but if maybe it's because you have not now studied this type of things. Number 2, you have not jumped into, you have not looked at how, like sometimes even before you lie, you have to first lie yourself. Did you know that? You can never make a lie to another person before you. So even you practice. So before you lie another person, you first lie yourself. Yeah, and prepare yourself how, knowing that it's a lie, how you're going to lie. Even when you're talking to the other person, you're very busy trying to convince them. I've already lied to myself that this is a lie. Now I'm convincing you. That's why we're able to use electronic machines to create lie detectors. But somebody will say, this is just technology. You understand? Okay? So a declarative statement that is either true or false and must have a subject and a verb. So you may have a subject through which you're making assertions. And we want to find out whether the assertion that has been made is true or false. Sometimes we use evidence. And that's why you see in science, we have what we call opinions and facts. You know the difference? At this level, as you are doing discrete math, you are getting into science. You now have to remove opinions from facts. What are facts? Are you hearing this for the first time, or you don't know how to? Current. True. You mean can you get opinions that are true? So, like he's saying, facts are things that can be backed by evidence. Opinions are things you say, but you can be a very good speaker. And you speak a lot. But if you're speaking with somebody who believes in facts and is only trying to get facts, he's listening to you, but he's only looking for facts. Once you are done, he'll say you haven't spoken. Then you're like, but man, after I've been able to unleash. So sometimes, depending on the audience you are speaking, you might talk and talk and talk, and there's nothing that you have. Okay? We had a presentation to one of the boys from in the Uganda North American Association. Okay? And then he was presenting about the startup ecosystem of Uganda. But now the people in the diaspora, I think because of politics, for some reason, everything they just hammer. Because they were like, oh, now legal system in Uganda is bad. Say internet and whatever is bad. And then now for us, we are trying to make sure, you guys, you are in the US, but US is not your home. You'll have to. So when this gentleman came to start the presentation, he did not even say that politics or this. He was just saying the startup ecosystem in whatever that we're dealing is about this $1 billion. The number of startups that have succeeded, we have had the Safe Border, we have had the Jumuiya, we have had the Kira Motors, we have had, and the man started just outlining startups that have, and their portfolio in terms of $1 billion. You understand? Then he said these ones are in the logistics, these ones are in Nakawa. Currently, we have about 19 of them. These are in agri-tech, these were in fintech. Now, by the time he finished the presentation, those Americans, the black Americans, Ugandans Americans who were there, everybody was just like quiet. And sometimes, by the way, when you are discussing things, they can look like they are so rude. And now this gentleman is just in Kampala, showing case what he has been doing. How he started his thing, I think, in 2017, and he has attracted, he has a current project, I don't know how many $1 billion. Yeah. And it's just an app that handles logistics. So what the man was saying from the facts, that for you as you are discussing what is not working, for us with the little that we have, this is what I'm able to do. I have moved from having no capital to the ability of attracting angel investors, to the ability of attracting international investors, and this is what I'm able to do. So if somebody is now talking about $1 million attracted here, and for you are talking about just government, you will talk, and there's nothing much. So facts, there are things that come up with evidence, and it's one thing that you have to learn whenever you are speaking to make sure you bring them. So propositions are used to study the meaning of statements and relationships between them. Example, Kampala is in Uganda is an example of a proposition. Okay? Kampala is in Uganda. You know Kampala for sure is a capital city. You know where Uganda belongs. Is that statement true or false? So to the computer, it's not going to look at Kampala is in Uganda. It is simply going to look at a true statement, and it will assign that statement value 1. Okay? 3 plus 5 is equal to 4. Now, the normal logic, 3 plus 5 is equal to 8. So which means that that statement is false. So in a computer, that statement is 0. It is told, okay, is a proposition because the statement can be evaluated to be either true or false, and once actual facts are established, then if it is declared told, it can be, but this one could either be true or false. But because, okay, here I think they try to say that it's true because it's already asserted for that person to be told, but it can either be true or false, okay? Now, what is not a proposition? Questions are not propositions. For example, is he tall? Now, there's a difference between a declared statement. You remember how God created earth? Let there be, okay? Let there be water, and water, okay? So when you're having a declarative statement, but of course when we go there again, now those are not facts. I'm a Christian, but don't take me back. Because they have so many arguments. There are so many arguments about a Muslim would have his way, and we still have to allow that. A Christian would have his way, we still have to allow that. Mama Fina also, these days I've picked interest in her TikTok, because I'm trying to understand. And she proudly comes and says that, for me, if you want me to Sirania, to make somebody, you come to me. But so I try to ask, where does this woman get motivation that what she lives for on earth is to make other people miserable? Okay? Now, when you look at that, it also tells you that God's things are also real. Because by the time somebody wakes up in the morning and covers in bed and sleeps and wakes up and makes sure that, come to me, I want to make person's ex-life miserable. It means that when we say that the human heart is dark, this is serious business. Okay? So anyway, he is tall is not, no, is he tall is not a proposition. 2 + 3 is not a proposition. So that's why we say that a proposition is a declarative statement that can be evaluated to be true. Because it means that by the time that statement is made, you must be left guessing whether the statement is true or false, because you are now looking for facts. I don't know if you get what I'm saying. Because if I say he is tall, you are now waiting to see who is this tall, so that you can evaluate whether he's actually tall. If I say it is raining, you are waiting to see whether it is raining or not, to see whether it is. You understand what I mean? But if I say, is it raining? Yeah, I'm again looking at another person to confirm that. So we say propositions can be simple or complex. If you have one statement, that is a simple proposition. But you can create complex propositions by joining one proposition to another, or maybe 2 or more propositions. But now, by joining to get a complex proposition, you will need what we call logical connectives that allow those propositions to be combined until they make a very complex statement. Okay? How many statements have I made since I came here? Many. What I've been doing is that I've been speaking about simple propositions to make a certain combined statements that and transfer certain message. So I've made a number of propositions combined with different connectives to make what I am talking about. And we shall see some of these connectives just from words like and, or, and stuff like that. Now we can go back to, okay. Now in propositional logic, we don't care for the literal meaning of the statement, but we're interested in the truthfulness or falsehooodness of that statement. A true proposition statement is assigned value T for true or 1 for true. A false propositional statement is assigned value F for false or 0 for false. Now you can see how we are moving from a full statement to a mathematical derivative in the computer. Okay? Different logical operations can be carried out on simple proposition to form what we call complex proposition. I've told you proposition can either be simple or complex. But to make them complex, you use logical connectives. So truthfulness or falsefulness of complex proposition shall depend on truth or false status of simple proposition and the type of operation used to operate on the simple proposition. Now, what are we saying? You have a simple proposition which is true. You have another simple proposition which is false. So if I combine proposition 1 and proposition 2, what is the truthfulness of the complex proposition? So what we are saying, that the truthfulness of the complex proposition depends on two things. One, on the truthfulness of either the simple proposition or depending on the type of logical connective that was used to combine the simple proposition. Are we together? So the computer, as it carries out its arithmetic, it will determine the truthfulness of the complex proposition depending on the type of operation that has been used on that proposition or the truth values of the simple propositions. Now, we can use, while I would say he stole, in computer we usually use what we call variables. Variables, okay? Propositional variables. Have you come across the words variables? If, for example, I say he stole, instead of writing the whole statement he stole, I can represent that statement he stole by just saying P is equal to he stole. So now that statement P is what we call a propositional variable. It can be P, it can be X, it can be Y, any small letter, it's not a number. Any small letter replaces the long statement. So when the computer looks, because remember that some of those variables, we can store now that statement in that variable and just start using the letter to represent that proposition. So for example, a proposition, Henry eats apples, can be represented by proposition P. Also another proposition, Catherine eats chocolates, can be represented by preposition variable Q. Are we together? Madam, are we together? You're sure? Okay. So simple proposition P, Q can be either true or false. Okay, before we look at those logical connectives, I want us to go back. Where do we apply these propositions? Do you know that man? Aristotle, 384 BC to 322 BC. Now for you are here, hey, today is money AI. Tell us 384 before Christ. Is it BC before Christ? Can you imagine? These fellas were there before even Christ was born. And that is also before our Prophet Muhammad. When was Prophet Muhammad born? Those who are Muslims. Nobody is a Muslim here? Yeah? So, if you're Muslim, behind you, and you're Muslim, hey, we are asking Muhammad, when was he born? Or you don't know? Okay. No, but we just use this for inference. We are trying to appreciate people who have made a very substantial contribution to what we are today. People like Aristotle. These are things they started debating. Okay? And that was 384. Now, Aristotle was a pioneer of logical reasoning. Yeah? So when you see things happen, these are people who started looking at things and asking, why do things happen? We just move as human beings. Are we proper? You see, like the way the world is confused today, until you don't know. You're finding a whole president of the United States and the one of Zelensky is for which? Yeah? Ukraine. They stand before there, and now you cannot be sure whether what they came to discuss there is valid or not, and you wonder where the world is going. You understand? So, these people sat Aristotle, before even Jesus came, started saying, no, there is a way we need to think and format certain things. These are the fathers of science, by the way. They are the fathers of law. Today's law we are looking at. Even before. Okay? So that's why sometimes we say science and religion does not necessarily conflict. Each one serves its. Yeah? While religion is open, it could be opinions, it could be subjective, because we interpret. If you found a Muslim here saying why Allah is, why Prophet Muhammad is the only, he will be very correct in his, and he has, okay, his assertion. Then the Christian will come, Jesus is the only way. Then somebody will say the heaven. But I mean, some things we have to go slow. If God has given us the grace, you do things you are supposed to do. Don't start hiding don't start hiding in things you want to start explaining. Even in church, I usually tell there are people who are hardcore preachers. Then when you find them, they go, let me go and, I tell them just preach and do your work to make sure people's hearts get better. But if we put you on scrutiny here, you will even go back and sit down. So you do the work because we know we need good hearts, but don't impose what you believe on others. So pioneer of logical reasoning. Now, propositional logic also provides the theoretical base for mathematics and computer science. You're going into AI, part of, we are opening your skulls and trying to interest you in other ways of reasoning. You will find it in practical applications in computer science, design of computer machines. Okay? You will also find its application in artificial intelligence. Now, artificial intelligence has come all the way, they will talk about 1950s when you have the modern computer. But this man started talking about logic ways 300 and whatever before birth of Christ. Because for us, we know that birth of Christ was around 2025 years ago. Yeah? But this man, this is about 380 something years before even. Yeah? So, you can see that the basis for which the artificial intelligence has come to work today is still based on this thinking. It's used in definition of data structure for programming languages. Some of you here into programming, as you apply that logic to think. Okay? Because there are things people will tell you how they arrive at certain thinking, and you just can't comprehend. Your brain cannot, because it's not yet there. Okay? Because you've heard of people who have gone to the moon. You know that there are people who have gone to the moon. Yeah? What on earth were they thinking? Yeah? Somebody sits there and thinks, what is there on the moon? How do we get on the moon? And they design a system until they go to the moon. Do you think that person is still struggling with his brother about, say, this is where my land stops? Eh? He's still struggling that, oh, Smiley, this is a relative of mine. By the way, if you want also to know where your brain is, and you can do the evaluation yourself. If you are still in your mind that, oh, this brother of mine, Smiley, this, just know that the usage of your brain is still somewhere. You are still locked somewhere. Okay? Because people sit and think things that they are so disturbed about solutions to the extent that things that are disturbing their problems are not even here. Yeah? And if you want to think about it, I mean, that's even in relation to the problems we have in Africa. Yeah? We are here now training students, but students are just occupied. Once I get this, my job improves, blah, 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 and the brain keeps rotating. I'll improve my salary. After the salary improves, I'll change the girlfriend. After the girlfriend changes, my dress code will improve. After my dress code, the car will. That's how the brain is thinking. That cannot be productive. It's just below the belt. Okay. So I just wanted to throw those insights about Aristotle and possible applications of propositional logic. Now let's go to logical connectives. Logical connectives. Now we have different types of logical connectives. There are about 7. But the 3 primary logical connectives are either or. I don't know how I should put this. Now, when we're making statement, you are combining one statement to another. And the word you are using in between is either dash dash or. Okay? Either or. That is an example of a logical connective. But the simple way we call that, we call it an or. Okay? We call it an or. Okay? So for example, if you say, we had statements up there. If you said, Henry eats apples. Okay, either dash dash or dash dash. So that statement would be like, either Henry eats apples or Catherine eats chocolates. That is a complex proposition that has been joined by a logical connective, either or. Am I making some sense? So one of the logical connectives is the one that has either or. But sometimes we can just say that the logical connective is an or. Okay? Now, if you're using an either or, mathematically, that is an addition function to the computer. So for you in the language narrative, you will say either Henry eats apples or Catherine eats chocolates. But we know that Henry eats apples is represented by which variable? P. And we know Catherine eats chocolates is represented by which variable? So mathematically, the statement either Henry eats apples or Catherine eats chocolates can be represented as P plus Q. Are we together? So I can be able to convert, or you can be able to convert a statement from a linguistic nature into mathematical. Okay? That's why sometimes there are people when you talk carefully. Because for you have spoken 50 statements, but the man has made a mathematical formula that has analyzed what you have said, and he has already concluded. Even before you finish, the rest is not bothered. You understand? So that's why, depending on people you want to lie to, you lie very carefully. You want to find out whether the man is he's a Boolean man. He's a mathematical man. Because for you to speak, he has assigned X plus Y. So however much you speak, he already has he's just waiting for you to finish. Then he asks you questions, and then you lock yourself inside. You understand? I usually tell people, I had a colleague who was, they accused him of murder of his wife. Okay? And when he went to court, okay, they allege he went, I think, of course, with his shoes, went, committed the murder. After committing the murder, carried these things, went with them to the house with the shoes, burned all the other things. And then when he went to commit wherever he was going, he had to keep on being given information that the wife was at the venue. So the man went with his phone, carried out the action. After carrying out the action, he then tried to, go back where he was. He burned all the other things, and he was like, "I'm now done." But there are things sometimes they look after an action of murder. There are things they look at before, during, and after, how a normal human being is supposed to behave. Or sometimes the proximity to the crime scene. Okay? So when the man went to court, for him, of course, he said, "Oh, no, it is so unfortunate. My wife died. I was never involved. In fact, when she died, they just started asking him very, very simple questions. Tell us about, do you have anything to do with this murder? No. When did you talk to your wife last? Where were you on this day? I didn't travel. I was with our friends, whatever. Okay, where? At what time? Which friends? You see now how, what the judge is doing. He's trying to make sure he first leads you to confirm all, because remember, you are lying. So you are first lying yourself. I had friends, I was at this, and remember that if you know that the murder was committed in Kansanga, you want to be as far as possible from Kansanga. So you will say, I was even in Entebbe. That is okay. You are in Entebbe. What time was that? It was at 6 p.m. because you even put the time when this murder, so that you completely, whom were you with? I was with so and so. Okay? And now these people, once you mention, I was with Maganda, I was with whatever, I was going to say, okay. And then they find the Maganda and whatever. Where were you on this day? What is going to happen? They might also try to lie. Yeah? But now remember, these days, this thing here is a killer. They just go and try to print where you are. Now, for you are saying you're in Entebbe. Now they come back and ask you, if I confirm to you that at 6 p.m. you are in Soroti, am I lying? No, me, I wasn't, blah, blah, blah. Okay. What about you? No, for me, I was also. What about you? Me, I was also in Entebbe. Okay. Then they go back on the printout and say, you are in a restaurant in Soroti. They bring the restaurant manager, they bring somebody who served you and ask him, can you identify this so and so? That, well, this person was in Soroti at this time. And if, for example, you committed a crime, possibly you are even going to spend the night. You understand what I mean? And now somebody was at a hotel. They say, okay, bring out the receipt. Is this a lie that you slept at this place? Now there, you start sweating. You start sweating. Then you start contradicting. Then they ask, why are you lying on this? So they went later. They say, okay. They brought whatever to go inside and check anything that was inside. And they pulled the shoes, checked on the whatever's on his shoes. And they found the soil. Now remember, sometimes even when you're committing crime, you're not an expert to know all the intelligence that is available to be able to. And they checked the soil sample there, the soil sample on the other side, and it was time. They looked at the phone, the proximity to the community, whatever place it was there. They got other people who were able to look at the previous instances, and so the man was given 25 years. Now, it might not be true because also people can fabricate it. But now the problem this guy had, he was a poor man, but when he became an MP, he was our friend. He could say, for me, I slap and I pay. You understand? And so he could just give slaps, and then the next time the girlfriend, whatever he says, you can go to Dubai and do the shopping. So our ladies also, okay? But the point I'm trying to make there is how sometimes those connections can be made to make certain meaning, okay? So I was saying, Henry eats apples and Catherine eats chocolates can be represented using an either or. Now, we have also another logical connective, and where you make a statement, okay, now before that one, you can use the symbol of P plus Q, or you can use the symbol of P, V, Q. That is still the same. That is still the same thing. You can use a plus to show either or you can use a V between the two variables. So if I say P plus Q to mean either Henry eats apples or Catherine eats chocolates, I can also represent that statement as P, V, Q. Are we together? Yeah? But you look like you're doubting me. Now, another logical connective is an and. An and. Where I can have P asterisk Q. That is the same as Henry eats apples and Catherine eats chocolates. So I can represent Henry eats apples and Catherine eats chocolates as P asterisk Q. Or sometimes you can just say P dot Q. Okay? Now the truthfulness, remember we said for those statements will depend on the truth values of the propositions or the type of logical connective. So where you use an and, we shall get different types of results. Where you use a plus, you shall get different types of results. Then you can use another logical connective called not, which is usually called a negation. And as you can see, the symbol could be a hyphen at the top, a negation sign at the top. If, for example, you had Q and you had Henry eats apples, which is represented by variable what? P. If I want to show Henry does not eat apples, I don't have to write another statement. I just show P and I write a hyphen at the top. Or I can use that other symbol there before P to show that Henry does not eat apples. So those three, or not, and form the three primary logical connectives. The others I'm going to read are a combination. So you can combine not and not and or. Okay? So the third one is nor, where you use that neither Henry, you can say neither Henry eats apples nor Catherine eats chocolates. Neither Henry eats apples nor Catherine eats chocolates. Okay? Then the next one is none. So you're combining and not. Then another logical connective is either or but, not both. Now this one, when I say either or, don't just find either or and conclude. There is one which is only specifically either this or the other one. But there is one which has, you'll find it saying either Henry this or Catherine this, but not both. It means something else. Then we have X nor, neither, but we are going to see those examples, so don't worry. Neither Peter does this, nor Catherine does that, but both. Okay? Then, of course, we shall look at conditional statements of if then, and then the biconditional statements of if and only if. Now, let's start with the inclusive or. So, logical connective or is used to carry out an addition operation on logical statements. In sentence format, it's represented by either or. In symbolic format, it's represented by a V or a plus. Example, let B be the proposition Henry eats apples, while Q be the proposition Catherine eats chocolates. Okay? So, a logical connective or, which is either or format, can be used to join two or more single propositions into compound proposition as follows. Either Henry eats apples or Catherine eats chocolates. And this can be mathematically represented as P is equal to Henry eats apples, Q is equal to Catherine eats chocolates. So you can represent it as P, V, Q. Or you can represent it as P plus Q. Okay? Now, sometimes you will find that because P has changed, after you add P to Q, because P plus Q has changed, you might assign it a new value, maybe 1. You understand what I mean? Yeah? Now, for every connective, we use what we call a truth table to evaluate possible truthful outcomes, possible truthful or falsehood outcome that will happen as a result of using that operation. My friend, are we together? Okay. Truth table. Remember, I was telling you about the judge. We have possible ways of how you are going to lie, and there are also possible ways of how you are going to tell the truth. And then we have accepted means of gathering evidence of what you are saying. Either make meaning or not make meaning. So likewise in the computer uses what they call a truth table to come out with the possible ways of evaluating whether the statement that it has been given in relation to what has been declared already to be true or false. So a truth table is a method of mapping out all possible truth values in an expression together with their resultant output for a given logical operation. So from the start, each logical operation has its own truth table. And it's that truth table that dictates how the complex proposition. Now we are looking, when you have this simple proposition, you already know that this is true and this one is false. But for you to know, you use now the truth table to know that if a simple proposition with this truth value are combined using this logical connective, these are the possible ways in how they can be true or false. So an example of using truth tables in computer is that of analyzing Boolean expressions used in controlling branches and loops in computer programs. That is how the truth table looks like. That is how the truth table. So we are going to start with a truth table for an inclusive or. Now you want to be very attentive because these are things They are very common questions that come and students even have, even if you tell them, you have this statement, draw its truth table, draw the logical expression, draw the, yeah? And the students look and go. So, what the truth table has, on one side, the left-hand side, it has what we call the input. Then on the right-hand side, it has what they call the output. Okay? Now, what do you note on the input from what I've taught so far? At the very top of the input, what do you have there? Propositional variables. What are they representing? They are representing the proposition. So in other words, on the left, you have propositional variables. But what those propositional variables are doing is that they are representing the propositions which are included in that calculation. Now, on the right-hand side, on the output, what do you have? Yes? What are you seeing on the right-hand side, my friend there, from Somalia? Well, are you from Eritrea? You're from? Sudan. Okay. What do you see on the right? Here. What do you see? PVQ. What is it? Is that the same as P and Q? We are now seeing the mathematical, that we are seeing that this truth table is one where P and Q is being added. We are having a logical operation called addition or an either or. So, and which is represented as P, V, Q. Or it can be represented as P plus Q. Okay? Now, at this point, do we know whether Henry eats apples? There's an assertion that Henry eats apples. Do we know whether Henry eats apples? I'm asking you because it has been declared there. And we know whether Catherine eats chocolates. We don't know. You do. Do you even know Catherine? This is an assertion. Remember, we are creating thinking. So here, if you need is yes, now we are correcting because we are trying to teach you facts. Because I'm making an allegation, I'm making a statement you are not privy to. So I've told you, Henry eats apples. You don't know. I'm telling you, Catherine eats chocolates. You don't know whether it is true or false. So what happens? That on the left side, you try to create possible combinations of the statement. Yeah? So, now because there are two variables, the number of rows that you are going to have will be 2 to the power of number of variables you have in that statement. How many variables do I have in that statement? There are 2. So 2 to power 2. So I will have 4 different combinations of the variables on the left-hand side. Okay? Stars. I can see when stars are running in the mind. But it's okay. Are you getting the concept I'm trying to build? Okay. So, if there are 4 different ways, we shall say that, and by the way, when you see FF, you can use the left side to still see what I'm putting on the right. That on the left side, I'm using letters F to represent false and T to represent true. But on the right-hand side, I'm using zeros and ones. 0 to represent false and 1 to represent true. So you can either represent a truth table as this or for an inclusive or. But of course, in the computer, it is better to use this one. Okay? So now we shall start creating the truth table. And say now we have variable P, we have variable Q. Oh, this doesn't show. Are you able to see the cursor there? Okay, so you will have P and Q. So the first combination, because we want to combine it 4 times. So we want to start it from the false value. So we say we want to start when it is false that Peter eats chocolates. And when it is also false that Catherine, that Peter eats apples, and when it's false that Catherine eats chocolate. So we can represent that as F. Okay? Now we go to the second. We want to start when it is false that Peter eats apples. But it is true that Catherine eats chocolates. Then the third one we want to have it when it's true that Peter eats apples, and false when Catherine eats chocolates. And the last one, you want to have a true value that Peter eats apples and Catherine eats chocolates. Now, on the right-hand side, you will see it more clear. You start it as 0, 0, 0, 1, 1, 0, and 1, 1 on the input side. Now, if you go back to your binary number systems, you realize that 0, 0 is a what? In our normal numbers, 0, 0 is a what? Yeah? How do you write 0 in binary? Yeah? Class 4, class 3, 1. 0, 0 is a 0. How do you write 1 in binary? 0, 1. How do you write 2 in binary? 1, 0. How do you write 3 in binary? 1, 1. So you will see that I have started from 0. In fact, if you come on that table, it means I've started from 0, 1, 2, 3. And that represents the 4 rows. Okay? Now, that is about the input side. The output. Now, the output of the truth table, we said it will depend on what? 2 things. 1, come again? The logical connective used, yes. In this time, which logical connective have we used? Or. Or. Okay. So, means that the output you have here, whether F true, whether that F is true or false, will depend on whether those statements are true or false, each of those individual values, and the logical connective used, and or that is used. Now listen carefully, because this is where now, much as we say don't cram, there are where things reach and you find.
Excuse me, Mr. Maganda. Excuse me, sir.
Now, the rule that determines whether you will have an F or will have a true on the output, the other side, is that when you are using an either or logical connective, so long as there is any true value among the propositions, the output will always be true. You can only have a false value where all the truth values are false. Have you understood? Because I've said cramming. Now that cramming is not in my head. You first cram in your head, then we go back. Yeah? First cram, first cram in your head. That for you to have either an F or a true on the other side, the rule is that so long as there is any true statement among the true values, if you are having an or there, which is called also inclusive or, okay, you will need to have at least a true value this side. You can only have an F if all the input statements are false. So now you see, so where we have F and F, what do you expect in that row? A false. Where you have a false and a true statement in the second row, what do you expect on the output? Why? Okay. In the third row, a true statement and a false statement. What do you have? You have a true and a false statement in the third row. True. Then you have a true statement and another true statement. What do you have? Yeah. So you don't say now we have two truths. Two truths. There are those who say this is the 1 plus 1, like the other side. People now have problems. You have 1 plus 1. No, this is logic. So don't say those are 2. That is 1 plus 1, which is 2. No, that is still, we are saying a true statement and a true statement gives you a true statement. We are not saying 1 plus 1. Logic. Yes, you're excused.
I'd like to know whether that must be the order of the table. Should you begin with false like the way it is, or you begin with any values and for as long as
any values like what? What do you mean?
What I mean, you begin with any kinds of truth values for as long as the output matches, or it must be in that order.
Organization is key because that will confuse you. Because if you have others, you can begin from the bottom. Maybe true, false, false, true, or false, false. But remember, I'm trying to be nice. You understand? I'm trying to be careful. So you would rather get this structure. But if you get it in another format somewhere where they have turned, it's okay. But I'm being very careful. Yes?
Just to be clear, if there were like 3 propositions, does it mean that truth table in the output side will power the variables to 3 to get 6 lines?
Will it be 6 if there are 3? It's 2 to power. 2 to power. So it will be 2 to power 3. So there will be 9 rows. You get it? We have 4 there because it is 2 to power 2. So it's 2 times 2. But the other one will be 2 to power 3, which will be 9 rows. So, hey, was your question answered?
Yes.
Excuse me, Mr. Magan.
Now, interpretation of OR truth table. When 2 proposition variables P and Q are logically connected using an OR operation, the computer with this binary form will evaluate the resultant complex statement from 2 to power n possible inputs, where n is the number of proposition variable, for this case 2 variables P and Q, and 2 to power n is 2 to power 2, which is equal to 4 possible input status with subsequent 4 possible output status. Interpretation rule for OR operation: any input combination with any of its individual inputs having a true value will result into a true outcome after the logical OR operation, or otherwise false result. So this is digitally, this is digital English, but I've already broken it out down into, just know that if you have truth values and you have any true statement, the rest will be. Okay. I sometimes, for those who believe, we say, where God is, nothing is. You can use that maybe to interpret also religiously. Where God is, nothing is impossible. So long as there is God, it does not matter. Smiley, you have smiley this fault which looks like this, you have no. So long as God element is there, everything is true. But also that means it will apply also to Satan. That there is a table whereby, so long as there is any false value, irrespective of what you have in that table, everything will be false. Okay? So if truth value of P is equal to false and Q is equal to false, the result of P plus Q is false because none of the input has a true value. If truth value of P is equal to false and Q is true, then P plus Q is equal to true because one of the input Q has a true value. If truth value for P is equal to true and Q is equal to false, then P plus Q is equal to true because one of the input has a true value. If truth value for P is equal to true and Q is equal to true, then P plus Q is equal to true because both P and Q are true. So that's the all truth table of two variables PQ with all four possible inputs and four possible outcomes will be as follows. The output is true for every input combination except when both inputs are false. Then the output will be false. Okay? Now, the type of OR we have looked at here is what we call, there are two types of OR, by the way, as we shall see later. This OR where we are having just an addition is what we call inclusive OR. So, but we shall see what we call an exclusive, the one where we say either or, but not both. Okay? Do you have another class now? At what time? At 10. Now some people are even making, yeah? Can the brain take up another truth table? Okay. I don't want to disorganize. Let me go with the little that I have put there, other than trying to disfigure. Okay? Yeah, but yeah. So you will appreciate that some of these concepts you don't want to come, you don't want somebody who is lame to come and help another lame person. You understand? You are going to end up into. Yeah? I hope you are around next week. Okay. Because these are things you will want somebody to explain, and if he explains to you he's just going to, instead of telling you that get back to the road, he just direct you to the forest. Yeah? Okay. So our cut will majorly be on these three topics: propositions, sets, and relations. Yeah. I hope we can. When is the cut? Yeah? This is week what? Week 5 or week 6? This is week 6. Really? I think it's 5. Week 6. Anyway, we shall. I don't know. This topic is a little bit. It's a little bit high voltage, and it's critical. So it will need, at least to understand, might need 2 more classes. Otherwise, if I teach at a normal speed, I'm just I will have fulfilled my duties, but then I will have issues with the understanding. Yes, Matov.
Yes, Mr. Maganda.
Yes.
Morning.
Morning. How are you?
Okay. Okay. I'd put my question in the message section, in the chat section.
Oh, sorry. I think I was just teaching. I didn't. Please help the relationship between propositions and probability. No, probability is completely a different topic. Yeah, it's complete. Yeah, I think Muganga had said well. I don't think they are related in any way. No, they are not. Probability is something else.
Okay.
Okay. Okay. That's all for now.